So we're just going to go ahead and do a quick review of our graphing techniques and just make sure we understand the difference between a vertical stretch, a vertical shift versus a horizontal shift, so on and so forth. So here we're just going to be playing around with the square root function. So if I have the square root of x plus 4, notice that 4 is outside of the square root function. So I think of my parent function looks something like this. And that plus 4 is going to shift the graph up 4 units. And so my graph will become this. That's the point 0, comma 4, 1, comma 5, 4, comma 6. Everything gets shifted up 1. If the 3 here is underneath the square root, that's a horizontal shift in the opposite direction. So that's going to shift 3 units to the left. So 0, 0 gets shifted to negative 3, comma 0. 1, comma 1 gets shifted to negative 2, comma 1. And then 4, comma 2 gets shifted to 1, comma 2. So you have to be very careful. You have to watch where those numbers are at. In C, this is a vertical stretch. So now I'm going to stretch all my factors of y by a factor of 2. So it's like I'm going to be doubling the y coordinate. 0, 0 stays put. 1, comma 1, I'm going to double the y coordinate. It becomes 1, comma 2. 4, comma 2, I'm going to double the y coordinates. It becomes 4, comma 4. So 0, 0 stays put. This is now 1, comma 2. And this point out here is 4, comma 4. Here we have a horizontal shift of 5 to the right, and it's also reflected across the x-axis. So I'm thinking my point 0, 0 gets reflected, so it stays put, and then I'm going to shift it 5 to the right. So it becomes this point here. 1, comma 1, I get shifted to the right 5, reflected. That's now 6, comma negative 1. And my other point, 4, comma 2, gets shifted to the right. So that becomes 5, so that becomes 9, comma 2. And then it gets reflected across the x-axis. So that now is the point 9, comma negative 2. And this was the point 5, comma 0. Now this graph, so let me redraw my parent function. So this gets reflected across the y-axis and shifted down 2. So if it reflects 0, 0, stays put, shifted down 2 units, that's now the point 0, negative 2. 1, 1, shifted, reflected. So that's 1, negative 1, shifted down 2 units. That's now negative 1, comma negative 1. 4, comma 2 gets reflected to 4, negative 2, and then shifted down 2 units. And then this one, we're going to shift right 3 and up 3. So I'm going to shift 1 to the right and 3 up. So I pick up my 0, 0, right 1, up 3. That's now 1, comma 3. My point 1, 1, right 1, up 3. So that's now 2, comma 4. And my 4, comma 2, right 1, up 3. So now that's 5, comma 5. And that would be points. So just got to really watch where that square root is, because that makes a big difference. And same thing with any function. You got to identify what's inside next to x versus what's being added to or subtracted on the outside. Now let's go through and do some exercises where we got the graph, and then we need to come up with the equation. So the first step is identify the parent function. So this is a V shape, so that's the absolute value function. And we see it's been reflected across the x-axis. We see that it's been shifted 5 to the right and up 6. So let's just note all that. It's been reflected across the x-axis. It's vertically stretched by a factor of 3 and shifted 6 up. And we have the horizontal shift of 5. All right, so it's reflected across the x-axis and vertically stretched by a factor of 3. That's where that negative 3 comes from. 3 is from the vertical stretch. The blue minus sign is from reflected across the x-axis. Then it's x, and remember, if it's shifted to the right, it's a minus 5. And then up 6 plus 6. So let's try number 2. Pair of functions, x squared. It's been shifted 3 units to the right and 2 units up. It's reflected across the x-axis. And there doesn't appear to be any stretch. So there'll be no stretch or compression or shrunk. So let's just kind of summarize. It's reflected across the x-axis. Stretch, compression, none. Vertical shift 2 up. Horizontal shift 3 to the left. So putting all that together, there goes our minus sign for the reflection. It's x. Now it's 3 to the left, so I'm going to put a plus 3 squared and then plus 2 up. All right, let's go to the next example. So my parent function is the square root of x. It's been shifted 1 to the left and down 4. Now we do have a stretch here, because normally when you go from that point 0, 0 to 1, 1, you go up 1 over 1, but here we're going over 1 and we're going up 3. So we have a vertical stretch of 3. So there's no reflection. Vertical stretch by a factor of 3. It's shifted vertically 4 units down and horizontally 1 unit to the left. So my a here is going to be 3. My negative h is going to be a negative 1, so h will be, so we'll write minus 1. Sorry, minus a negative 1, which would be plus 1. And then shifted down 4 units, that's our minus 4. This next one is a V shape, so that's our absolute value function, so that's our parent function. It's been shifted horizontally 3 to the left, so that's going to be a plus 3 inside of the function next to the x, down to minus 2. And it looks like it's been shrunk a little bit here. Instead of going 1 unit over and 1 up, we went 1 unit over and half up. So my a here is going to be 1/2. So let's just kind of write that down. And then we put it together in our function. All right, let's try E. So we're playing with the x squared function. So that's our parent function. We're shifted 4 to the right and up 5. And it's also reflected. So A is going to be a negative. But if we go down 1 over 1, there's no compression, shrunk, or stretch. So let's summarize. Reflect across the x-axis. Oops, sorry. Let me do that, make it easier. Compression, there's none. It was shift 5 up and shift 4 to the right. So reflect across the x-axis, I need to put a minus. Horizontal shift to the right, so I need to put a minus 4. And then 5 up, plus 5. And now let's look at the last one here. This is my square root of x function. It shifted 2 to the right and 5 up. It's been reflected across the y-axis. That means we're going to have a negative in front of our x. So let's see if we can put that together. So it's reflected across the y-axis. The stretch and compression would be none. It's vertically shift 5 up, horizontally 2 to the right. Now it's going to be a little tricky how to write this function, because let's think about what it would look like before the reflection. So if I back reflect this, this would have been over here, and that would give me a plus 2. So the way we'll fix that, so when we write that down, here's our horizontal reflection. I'm going to write in parentheses x minus 2 plus 5, which then would simplify to the square root of minus x plus 2 plus 5. So that last one, when you got horizontal reflections, that's always a little tricky. So you have to be careful with those.